So we're here in our second video, and we're going to get started on some of the new stuff. And as you saw when we were looking at our triangles, we're going to be talking about triangle congruence. So what are the ways to prove two triangles are congruent? And again, what does congruent mean? Congruent means you can set one triangle on top of the other and they are the exact same shape. When we talk about lengths, we're talking equals. When we're talking about congruence, we're talking about lines and segments and angles and stuff that are the same. Congruent means they're on top of each other. Equals means they have the same measure. Okay, so we're going to show all the sides of two triangles. We're going to show side, side, side. We're going to show side, angle, side, and then we're going to do some of the angle questions. So those are the four that we know of now. There's going to be one more that works on a specific triangle. We haven't talked about that yet. Why doesn't showing all three angles are congruent in both triangles show that the triangles are congruent? Well, let's take a look here, see if I can draw a triangle. And I have a triangle there, and I have the same triangle there. What happens if this one is smaller? It has all the same angles, but they're not congruent because the sides aren't the same side. So we know that they can't be congruent just because the three angles are the same. Why doesn't side-side angle prove congruence? Well, let's take a look here, see if I can draw this. If I have a side that's that length, and a side that's that length, and an angle that's that measure. Could I also have the same side length, the same side length, and let me see if I can get that angle right. Same angle. Okay, basically we got this side here, this angle here, and this angle here, that angle there. They're all the same. But the triangles aren't congruent because you can have two cases when you know two consecutive sides and then an angle. But if you have the angle between those two sides, then we know that they're congruent. So side-side angle, because of this case here where you can have two different triangles with the same side-side angle. Can you ever have three? No. The most you can have is two triangles with the same side-side angle. So we're going to get to that when we get to pre-calculus stuff in the spring. All right, so let's take a look at this guy and see if we can come up with, I'm going to pause this and make that picture. Well, at least the top one is a triangle again. I was missing a side there for a second. So with your pencils, take a little time to actually A, B, C. That's that triangle. And then on the second one, they're going C, D, A. And so we're going to prove that these triangles are congruent. So I'm going to start out with the things that they tell me. I know that AB is equal to 12. I know that CD is equal to 12. I also know that BC is equal to 12 and DA is equal to 12. Those are all given. And just so you understand what I'm doing here, I'm doing a T-chart, a two-column proof for this first one. 2. If AB and CD are both equal to 12, can I say that AB is equal to CD? And similarly, BC is equal to DA. And I use substitution. If things are equal for each other, you can substitute them in. And so if they are equal to each other, I can say that AB is congruent congruent to segment CD, and segment BC is congruent to segment DA, and that's by the definition of congruent segments. Definition of congruent segments. If they are equal, then they will be congruent. If they're the same length, then they would lay on top of each other. Okay? And if that's true, I also know that segment AC is congruent to segment AC, and that is called the reflexive property. And that's a good one to remember, the reflexive property, because anytime there's a segment that's part of two triangles, then you can use the reflexive property for a side in each of them. So if that's true, I know that triangle ABC is congruent to triangle CDA because I knew that all three sides of one is congruent to all three sides of another. It's called side, 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 and we talked about that. Why is angle CAB, this angle, congruent to angle ACD, this angle? Well, if we look at where they are in the triangle statement, we're going to say that CAB, we're talking here, and we're talking there. If we look at our statements that we had originally, are they in the same position? CAB, first, or last, first, second, and ACD, last, first, second. Yeah, if you look at the positions of them, they are the same. And so they are congruent because, once you know that the two triangles are congruent, you can say that the corresponding parts are congruent via Cpctc. Corresponding parts of congruent triangles are congruent. Okay? So Cpctc, once the triangles are congruent, because you're going to be using the three-letter shortcuts, so side, 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 angle, side, angle, angle, side, and angle, side, angle. These are shortcuts. Those are only three things that you have to show. How many parts are there to triangles? Well, there's three sides and three angles, so there's 6 parts. Once we use these shortcuts, we get all 6 parts. So let's show parallel. Now, I talked about this in the review that we're going to use some of these converse things to prove. So let's get to our proof and see if I can do it. Let's start out with, and I'm going to use a 2-column proof again. I'm going to say AD equals 8, BC equals 8, and I'm going to say that those are given. It also says up here in the instructions that we're going to assume that AB is equal to DC. And that's also, I'm going to use that as a given also. So I know that if these both equal 8, that AD equals BC. That's our substitution that we used before. And we know that if they're equal, we can also call them congruent. So I'm going to go here and say that AB, segment AB, is now congruent to segment DC. And segment AD is congruent to segment BC. And I think we talked about definition of congruent segments before. We hit that one. And then, make sure you can still see the picture. What part is shared by both of them? Well, the AC is congruent to AC. And we said that's reflexive. Similar to the last proof. And so we know that the triangles are congruent. Triangle ABC is congruent to triangle CDA by side, side, side. Okay. But we're not done because we haven't shown the parallelness. But wait, there's more. If we know that angle BAC is congruent to angle DCA, let's go over here and look. BAC right here, I know it's covered up, and DCA right there. Well, if those two are the same, and we know those are the same because they're the same positions within the statement, so I'm going to go second, first, third, second, first, third. And so, yeah, because of the statement, we know there, and we're going to say because of Cpctc. Once the triangles are congruent, all the parts are congruent. And my last statement, I'm going to say segment AB is congruent to DC. And we know that's true because the position that those two angles are in are alternate interior angles. But we're not proving that the angles are congruent, we're proving parallelness. So we're going to have to write converse afterwards. Anytime you're proving parallel, you need to use the converse. Okay? Oh boy, I'm going to pause again and alright, if two sides of a triangle and an angle between them are equal to the corresponding sides and angle of a second triangle, so we're going to be doing a proof with side angle side, then the two angles are congruent. So we're going to show that we got parallel here. Don't worry about the A, it just didn't want to stay put. And we're going to use that C is the midpoint of AE. So let's go ahead and start out with what we know. I'm going to use a two-column proof again. We know that DC is equal to BC because they're both equal to 9. So I'm kind of skipping a step there. Did you see that? Once I get good at this, I can kind of use a little bit of a shortcut there. Step 2, I know that AC is equal to EC, and I know that by the definition of midpoint. So if we go and look what the definition of midpoint, it's something that makes it equal on both sides. That's what the definition of midpoint does. So I knew that it would be equal on both sides. Let's go to step 3. I know that angle ACB is congruent to angle ECD because they are vertical angles. That's another thing that we talked about in the review. And so I know because I have two sides that are equal to each other and the angle between them, I know that triangle DCE is going to be congruent to triangle BCA by side angle side. And to prove the parallel that they want here, I'm going to say, I think I'm going to go right to it by saying that AB is parallel to DE because I know that we have alternate interior angles converse. Alright, we know that this and this. Could I have put a step in here that says that those two angles are equal to each other? I probably should have put in there by Cpctc, but I was running out of time and I didn't want to do that extra step. I'm going to go to the next video.